Nth Root Theorem. If n is any positive integer, r is a positive real number, and theta is in degrees, then the non-zero complex number, r cis theta, has exactly n distinct nth roots and, right, small, I didn't give you enough room here. Okay, so there are n distinct nth roots or solutions, and the first solution can be found with DeMoivre's theorem. And it's going to look like this. You're going to have your polar vector r cis theta, but we're going to take it to the 1 over n power. Okay? There's going to be a fraction involved. So the nth root, 1 over n. Two, bless you, in solutions are evenly spread from 0 to 360. So what you've got here is you've got complex numbers in a plane. And we know that goes from 0 all the way around to 360. But what's going to happen is, let's say you have 4 solutions. If you have 4 solutions, then 360 degrees divided by your 4 solutions or your 4 vectors is 90 degrees. Those 4 vectors would have to be 90 degrees apart from each other. Okay? If there were 3 solutions and they were evenly spaced from each other or evenly spread, they would be 120 degrees apart from each other. Okay, so that's what I mean by that second part. You've got n solutions, but they're evenly spaced from 0 to 360. All right, so that's an important thing. That's an important thing. So when you solve using the Nth Root Theorem, you're going to do 2 steps. Find the first solution using DeMoivre's, and then find the rest of them using that other concept that they're evenly spaced. Okay? So, example 3, use the Nth Root Theorem to find all of the solutions. So, think about what you do in algebra. If you were solving the equation, you'd take the square root, okay? But another way of thinking about it is if I took the 1/2 power on both sides. If I took the 1/2 power on both sides, I might be looking at x equals 25 cis 90 to the 1/2 power. And that looks like DeMoivre's. DeMoivre's is taking a polar vector and raising it to a power. It just so happens that this power is a fraction. So we do what we do with DeMoivre's. We're going to take this 25 to the 1/2 power, and then we're going to multiply 1/2 times 90. And so if you're going to type in 25 to the 1/2 power on your calculator, make sure you use parentheses. 1/2 has to be in parentheses, otherwise it's only getting the first power. All right, so 25 to the 1/2 power is 5, and of course it is, because that's the square root. All we're doing is taking the square root, but that's 5. And then 1/2 of 90 is 45 degrees. Okay, so that's the first solution. So remember the steps up here. The first solution can be found with DeMoivre's theorem. That's what I did. That's the first solution. How many solutions are there in this question? There are 2. Okay, we know there are 2 solutions. So if there are 2 solutions and they are evenly spaced, then that means they must be 180 degrees apart from each other, yes? Okay, so let's think about this. If you have two vectors that are evenly spaced, yes, question? That's exactly what that means. All I'm going to do is add 180 to this 45, and I'll have my other solution. 5 cis, what is that, 225? Two solutions, 5 cis 45 and 5 cis 225. Now, if you wanted to change those back into rectangular form, that's fine, be my guest. But we're just looking at polar, it's fine. Okay? So look at part B. Part B, think about it. If I wanted to isolate x, I could do the 1/4 power on both sides. Okay? I'm going to take the 1/4 power on both sides. I'm going to get x equals 16 cis 120 to the 1/4 power. So DeMoivre says we're going to have 16 to the 1/4 cis 1/4 times 120. Well, 16 to the 1/4 power, maybe you can do that in your head. Parentheses around 1/4 is 2. 16 to the 1/4 power is 2. And 1/4 of 120 is 30. That's my first solution. Okay, the first solution we find using Dimos. How many solutions are there? We know there are 4 solutions. So those 4 solutions have to be equally spaced. That means they're 90 apart. So we just add 90 a couple of times, right? So if I add 90, I'm going to get 2 cis 120. I'm going to do it again. Add 90, and I get 2 cis 210. How do I know how many times to add 90? Right, how many answers I have, and I know I need 4 solutions, right? So just keep adding 90 until you get 4 solutions. So we need to do it one more time. Add 90. We're going to get 2 cis 300. There are my 4 solutions, okay? Are all 4 of those imaginaries? Yeah, maybe. I see an I in there. Cis contains an I. Remember that stands for cosine, I, sine. But, you know, if you changed it back to rectangular form, maybe that would make it easier for you to understand. You know, I don't know that I want to do that, I guess. Look at 2 cis 30. If I was going to change it to rectangular, I would go 2 cosine 30 and 2 sine 30. So I would have this 1.73, which maybe you recognize that number as square root of 3. Square root of 3 plus 1i would be one of my solutions in rectangular form. But I'm fine leaving it in polar. Usually what happens is if you start in polar, you can end in polar. Number 4 is basically the same thing. It says solve the equation and graph the solutions as vectors in the complex plane. Now, this is a little bit different because you don't have x on one side by itself, but just think about what you do in algebra to solve an equation. You'd subtract this 216 over, okay? We're trying to ISO the variable just like we always do. So let's subtract this 216 over. X cubed equals negative 216. Now, we can see how many solutions there will be. How many will there be? We know there will be 3, okay? We know there will be 3 solutions, but this one feels different than the last 2 questions because it doesn't appear to be in polar form. This lesson's really not that bad as long as we're in polar form. This is not polar form. In fact, it doesn't even look like it's a complex number, okay? Until you do this. Okay, now we can see that it's a complex number. Complex number in rectangular form, though. Nth root theorem only works in polar form. So basically what I want to do is convert to polar form and use my DeMoivre's and my nth root theorem. Okay, so think about what we have to do to convert. I want to convert, so I'm going to do r equals square root of x squared plus y squared. X is negative 216, so we've got negative 216 squared plus 0 squared, like that. Now, be smart about this. Okay, your 0 is just going to fall out, but your negative 216 squared square root, a lot of that's going to cancel out, right? Square root squared cancels out. Negative number squared becomes a positive number. That's going to end up being 216. Use a calculator if you need to, but you shouldn't need to. R equals 216 there. And then we can do theta. Tangent theta equals y over x. So tangent theta equals 0 over negative 216. Or tangent theta equals 0. Okay, so this one's kind of tricky, I suppose. You do an inverse tangent of 0, and you get 0. That 0 may or may not be the answer, okay? You have to think about generally what quadrant we're in or where we're at specifically. So don't write this down, but you're looking at this vector right here. Negative 216 plus 0i says what we would do is we would go, here's our axis. We'd go 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 blah. We'd go 216 in this direction. And then we'd go up 0. Okay? So negative 216 plus 0i looks like a really long vector going this direction. Okay? Correct? All we really need out of that is what angle am I pointing? What angle is that? That's 180, right? That's the information that I'm looking for. Okay? It's a 0 degree reference angle, but it's at 180. So let me get rid of all this. I don't want that there. I want theta equals 180. Okay? And so I've got r and I've got theta. I can rewrite my problem as x cubed equals 216 cis 180. Now, the thing that stinks is we haven't really done anything yet. We haven't solved our equation yet, but at least we're in polar, and now we can use nth root theorem. I can take both sides to the 1/3 power and solve this thing, okay? I can do a DeMoivre's. DeMoivre's going to say 216 to the 1/3. Let me try that again. Cis 1/3 times 180. And that's going to give me my first solution. X equals 216 to the 1/3, or in other words, the cube root of 216. Is 6. 1/3 times 180 is 60. 6 cis 60 is my first solution. How many solutions are there? 3 solutions.
Do we always add 90?
No, we don't always add 90. Okay? In this case, we definitely won't. In this case, since there are 3 solutions, those 3 vectors are evenly spaced in the plane. Those 3 vectors are 120 apart. So no, we're not going to always add 90. In this case, we're going to add 120. So, I'm going to add 120 a couple of times. If I add 120, I'm going to get 6 cis 180. And if I add 120 again, I'll get 6 cis 300. I'm just adding this 120. And those are my three solutions.
Mr. Booth, can I go? Like, will you let me go early?
Sure. So thing is here, if you want to change this back to rectangular form, you can. We're in polar, but we're right there. Okay. Give me a second. I need to graph this. Okay. 6 cis 60. Think about how we graph this. You want to look for a circle of radius 6. So 1, 2, 3, 4, 5, 6. You see that circle that corresponds with a radius of 6? You don't really want to trace that circle, but you want to kind of think about it. But you go to where that circle intersects the angle 60 degrees right there. So I'm going to follow that circle around to 60 degrees and look at that point. That point is the end of my vector. Right there. 6 cis 60. Do not go over that arrow. Sometimes people will make their arrow too long. 6 cis 180. So just follow that same circle. 1, 2, 3, 4, 5, 6. It's going to end up right there at 180. And 300, you want to follow that same circle. Radius of 6 at 300, it's going to be right where? Right there. So your result, you've got 3 vectors. Okay, it feels weird to call those solutions, but they are. Those are your 3 solutions. You've got 6 cis 60 degrees, and 6 cis 180, and 6 cis 300. Notice they're equally spaced. Those 3 vectors are equally spaced, evenly spaced in the plane, 120 degrees apart.